Hey, this is Mr. Hansen. I wanted to continue our discussion with about one variable statistics, and we're going to look at measures of center. So, when you're talking about a measure of center, that may be the best question to ask yourself, or maybe you do ask yourself, how do I fit in compared to other people? Am I average? Am I above average? Below average? And you could think of that in many different ways. If you're running a race, are you in kind of the middle of the pack, front of the pack, back of the pack? Or in terms of your grades, or in terms of your height, or anything like that. It's kind of a good question to know. Where do I fit in? Am I average or not? So the measure of center is going to determine if you're average or not. And there's a couple different ways to measure the center. The first way is to take a look at all of the data points and count them up. And we call that n. N is our sample size. And we divide by 2 and add 1/2. And so maybe if there were 10 data points, 10 divided by 2 is 5, plus 1/2 is 5.5. So let's just say 6, 7, 8, 10, 12, 13, 14, 1, 2, 3, 4, 5, 6, 7, 5, 2, 1. Here's 10 data points. So 5.5, we count in 5.5 units. So 1, 2, 3, 4, 5.5 right there. So halfway between 7 and 8, it would be 7.5 would be my median, or my measure of center. And that's saying that 50% of the data is to the left of us, and 50% of the data is to the right of us. So that's the definition for median. 50% of the data is to the left of you, 50% of the data is to the right of you. Remember, we can actually simplify this. We can say n plus 1 over 2. So the number of data plus 1 divided by 2 gives me how far I count in. So that's the median. The mean you may be more comfortable with. We usually refer to the mean as the average. And the symbol to find the mean looks like this. X bar is the mean, and it equals this E, this big here, is sigma. It's a Greek letter. It means add up all of your values, all of your x's, and then divide by the number of values you have. So this is the formula for the mean. We're just going to add everything up and then divide by the number of values we have. So right here I have some data. If I were to have interviewed maybe 28 people and asked them, how many siblings do you have? And if I were to get these responses here, you can kind of see that it's got a right skew. There are a few people with very many and siblings, and then most people have just a few siblings there. Let's find both the mean and the median, and then we're going to compare them and discuss which would be a better measure for the center. So if we're going to find the median, there's 28. I'm going to add 1 to 28 and divide by 2. I get 14.5. So I'm counting in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.5. So it's halfway between 2 and 3. So we just add 2 and 3 up, divide by 2, we get 2.5 right there, 2.5. I'm just going to draw a line. I'm going to call that the median. The median right there equals 2.5. So right there. Okay, now let's take a look at the mean. I've done a little bit of a shortcut with the mean. It's called the weighted mean. Rather than adding up 0 4 times and adding up 1 5 times and adding up 2 5 times, I'm just using repeated multiplication to make that a little quicker. So 0 times 4 plus 1 times 5 plus 2 times 5 plus 3 4 times, so 3 times 4 is 12, plus 4 3 times, plus 5 2 times, plus 6 2 times, plus 7 plus 8 plus 10. And then I divided that big number by 28, and I got 3.074. So here's the mean right here. Oh, a little bit closer to 3 maybe. About right there. Mean equals 3.0714. So why is it that the mean is to the right of the median? Why don't they just have the same value? And what's maybe the advantage to each of these situations? If you were to say that this person with 10 siblings and that person with 8 siblings moved the mean to the right, you would be correct in your appraisal of this situation. So when you have numbers that are pretty far removed from the cluster of data, they are going to move your mean to the right if it's above the cluster, and to the left if it's below the cluster, because you're adding in these large numbers. And so how accurate is the mean at really determining the middle? I don't know. If you have some outliers that are really huge, or some way away from the cluster there, you might have to question how reliable your mean is. On the other hand, the median just counts the middle 50%, and so it's not easily changed by outliers. Outliers aren't going to, if that 10 were a 15 way out here, it wouldn't matter. The median would still be in the same position. Okay, let's take a look at a new slide. Wages in thousands of dollars. So here I've got someone made 30,000, 32, 35, 40, 45, 45, 50, 58, 60, and then the person in this neighborhood who makes a lot of money, $250,000 a year. And so if I were to add all these up and divide by 10, I would get $64,500 is my mean. Does that seem reasonable to say that's a measure of center? It's more than this. It's more than the second highest number, so I kind of question that. Let's look at my median is going to be 45, right here, right between the two 45s. So my median, we just write the word median out, equals $45,000. That seems like a better measure of center than the mean in this case. Now, if you do go with the mean, there's something you can do to kind of recalculate things. You can say that this guy is so far away from the norm, so far removed. I don't know what he's doing in this neighborhood. He's just extra rich. He's got kind of an everyday house, but he makes $250,000 a year. So we're going to take him out of the data set. And we're going to add up the numbers again, except this time we'll just not add up 250 and we'll divide by 9 instead of 10. And the new median is x bar equals 43.88. Kind of interesting. It's even less than the mean there. So that guy definitely, and if you did this, you would have to mention somewhere that 250 was an outlier. It's kind of important that you note your outliers so people can believe your data. If you just throw out data anytime you want, people are not going to believe what you're doing. So you have to explain why you think it's an outlier, and then talk about how that changed your understanding of the measure of center there. One last thing on this idea of mean and median. If you have a mean and median that are really close to each other, what do you suppose that means in terms of the shape of the distribution? If you said that it's going to be a normal distribution, that's kind of what I was looking for. So in other words, and it doesn't mean you can't have outliers, because you might still have outliers, but those outliers might balance each other out, kind of like this. In this case, the mean might be right here, and the median would be about right there too. So when the mean and the median are close to each other, it just means that you're going to have a pretty close to normal distribution. There won't be a right skew or a left skew. Thank you for tuning in. I hope you learned something about measures of center. When you have a normal distribution, you want to go with the mean. because the mean will be helpful to us finding some other measures here later on. When you have a skewed distribution, you want to go with the median. That's the big rule for this lesson right here. Normal distribution, go with the mean. Skewed distribution, go with the median. Thanks again. Have a nice day.